Greetings, my name is Roman Nozdrin and I am software engineer in MariaDB ColumnStore team. As you all know, ColumnStore works the best with analytics workload. And today I will tell you what's new in analytics for MariaDB 10.5. The most important change is that ColumnStore doesn't need a special MariaDB server fork anymore. We also put 3 packages that existed previously into a single one and make it available in MariaDB repositories. We also simplified the installation process, so after the package installation, a single node cluster is up and running, so one doesn't need to run additional binaries like post-config anymore. To finish the convergence, we came up with the concept of execution pushdown handlers. These handlers are basically a paths that MariaDB could use to delegate the full query or the part of the query to the smart engine. And the smart engine is the entity that is capable of executing queries on its own. And there are 2 of them at the moment. One is a ColumnStore and another is Expand that exist in MariaDB Cloud. There are 3 execution handlers at the moment: select handler, derived handler, and group by handler. Select handler is used by MariaDB to execute the full query at the engine side. If it fails for some reason, for example, the query contains a feature that is unsupported by the engine at the moment, then MariaDB could try a derived handler if the query contains a subquery, for example. If a derived handler fails also, then MariaDB could also try a group by handler if the query contains group by or aggregate function. In the variant, there is a final fallback that we call table execution mode. And this mode supports all the features that MariaDB has. But sometimes it could be slower comparing to execution handler paths. The fallback capabilities differs from one engine to another, and for example, ColumnStore in MariaDB 10.5 can't automatically switch from select handler to other handlers or table execution mode in case of a failure. Luckily, there are session variables that one can use to explicitly enable or disable execution pushdown handlers. And you can see these variables at this slide. We also addresses the simplification of cluster starts and restarts. So now systemd is in charge for this, and it starts or restarts, if needed, processes of the ColumnStore cluster. And here is an example of the simple command that can be used to start MariaDB ColumnStore. And it is worth to mention that the whole startup procedure now takes seconds, not minutes. We also decides to delegate log management to both syslog and systemd. So you can now access ColumnStore logs via journalctl utility or flat files produced by syslog. We put cluster management, the multi-node cluster management, into a separate facility that we call the Cluster Management API, CMAP in short. This is a RESTful API that could be leveraged by either orchestration framework or can be used from a CLI via curl. The API itself is written in Python and very easy to use. Let's move on to different topics. ColumnStore, being a columnar engine, can be slow running a single inserts operation. So we decide to implement an insertion cache that speeds up the single insert statements a lot. Here's the table that contains the timings comparison when the groups of insert statements run with cache enabled and disabled. The second column in this table contains the timings when the cache is enabled. And you can see from the first row that running a group of 10 insert statements gives us a 10x speed up. So this looks significant. In 10.5, we still treat the cache feature as an experimental one, so we decided to disable it by default. And here is another important feature. We teach ColumnStore to store its meta and columnar file data on S3 backends. There is a separate process called Storage Manager that has an intermediate local cache that speeds up their operations. And roughly speaking, the query performance is almost the same as in local storage installations. ColumnStore prior to 1.5 has been a little clumsy when it comes down to encoding and collation support. So we decided to rewrite this, and now one is capable of setting both encoding and collation, creating a table. So later ColumnStore can use the collations running where clauses. And support for collation in group by or in join operations is coming soon. Here's the performance-related features implemented in ColumnStore. First is a parallel sorting that benefits the most queries that both contain order by and limit. One can control its behavior using this session variable. We also improved join and memory allocation algorithm. Here is a number of miscellaneous features. First to mention is that MariaDB will be a certified data source in the upcoming Microsoft Power BI release that is scheduled this autumn. So you can easily run queries in a direct query mode that speeds up the execution a lot. I want to mention that we changed our release numbering schema, so the next community release that should be 1.5.4 will be a 5.4.1. And with this slide, I would like to touch the base with what directions we're going to take in the future development of ColumnStore. Our most important target is the vectorization of query execution. So we will speed up the performance of ColumnStore even better. We also introduce table data sorting keys to orient the data on disk, and we add LZ4 as a compression method and improve our text columns encoding schemas. With that, I would like to thank you and wish you a very good day.
So excellent presentation, Roman, on the new developments of ColumnStore. Now, I'm particularly impressed that you managed to get ColumnStore to be a native storage engine in MariaDB. I know that this was not an easy task. Before we had ColumnStore as a separate binary entirely. And I know this, you've been working on this for a very long time. I think it's important that we showcase your work. And I think there's no better way we can do this except if I ask you some tricky questions. What do you think?
Sure, go ahead.
So first thing is, how long was it that you've been a part of ColumnStore, and how big is the ColumnStore team now?
I've been here since early 2017, and as of now, there are there are 6 of us, and there will be new members of the team soon.
Okay, that's quite a lot of people. So
yes, but the ColumnStore is a rather big project. It has about 7,300 lines of code at the moment.
That's a lot of code. So I think we should dive deep into some questions that I got from your talk. So let's see. First thing that comes to mind is ColumnStore is purposely made for analytics. But at which point do you recommend that I start using ColumnStore for analytical workloads? When should I consider moving from, say, just a simple InnoDB to ColumnStore?
Good question. I would say it depends. It depends on your requirements, specifically for how fast you want your queries to converge, your analytical workload queries. So if you want them to converge fast in, let's say, less than a second, you should probably move to ColumnStore even earlier than your database reaches 50 gigabytes. But as I said, if you're not concerned with timings, so you are probably be fine with even a 100 gigabyte database using InnoDB, because it can deliver the same results, but just in a bigger time. Okay,
that's interesting. That's a very good general rule that I can follow. Now, you mentioned that the work that you did for ColumnStore, to get it to be part of MariaDB, you had to implement some smart storage engine handlers that push the query down to ColumnStore.
Precisely.
Now, the question is, these handlers, you mentioned they don't always succeed in executing the query. What happens to those handlers, or how does the execution work when you have a cross storage engine query? One that uses ColumnStore table and one that uses say an InnoDB table?
Good question. Speaking of ColumnStore, it handles the whole query, even the one that contains cross-engine parts. So ColumnStore, on receiving such query, requests the part from InnoDB table using a MySQL or MariaDB client connection. And it processes the received data internally, using it as an originally natural data. Unfortunately, Expand at the moment doesn't have this capability, but they are working on this, if I'm not mistaken.
Okay, so you mentioned the Expand. That's another storage engine.
Yes, this is another smart engine that is very good in crunching many parallel OLTP queries. If I recall correctly, at the last OpenWorks conference, they had presented a cluster that was able to crunch 5.2 million queries per second. So this is an impressive number.
Mm-hmm. Yeah, I agree there. Now, it's very interesting that ColumnStore can actually query MariaDB on its own. So that makes me think that ColumnStore, in a sense, is richer than MariaDB when it comes to features. So is there, for example, a feature that is only available in ColumnStore, like a certain function? And how does MariaDB manage to pass over that query to ColumnStore? Won't it just give me a syntax error instead?
I would say ColumnStore feature list is a subset of that of MariaDB at the moment. However, there is a notion of user-defined aggregate functions that was introduced specifically for ColumnStore back in 10.4. This is a very good way to introduce features that MariaDB server doesn't have. it is basically a function, a user-defined function that could be run distributedly on in a distributive way on many nodes simultaneously. So the functionality of this UDEF depends on a user only, because we have a customer that use even machine learning capabilities, and they leverages UDEF for this.
Mm. Oh, that's very cool.
Yeah, I find it very handy, but it could be tricky to dig into this UDEF because it involves coding using a special framework. It is called UDEF SDK.
Mm-hmm. Okay. So I am familiar with UDFs a bit. I know it's quite hard to initially get it going, but I think after you wrap your head around the big chunks, then it gets easy to implement your logic. Precisely.
It is usually very hard to embark on some concept.
Mm-hmm. Now, another concept that you mentioned is that ColumnStore being optimized for columnar data and just getting your analytical results quickly, it falls behind when it comes to inserting data. So for that, so it was very slow when you were inserting a few rows at a time, and to make it faster, you added an insert cache to make it faster. But if it's a cache, do I have to worry about the ACID properties? Like, is my data inserted all in one chunk like I expected to, or is there some trade-off there?
Good point. I would say that working with OLAP engines, you shouldn't worry about ACID at all, because OLAP environment very widely utilizes the bulk load approach. I mean, most of the data is loaded in bulks. So it's not widely used operation. I mean, the singular inserts. So our cache works in a similar way. Under the hood, it uses a bulk insertion operation. So when it happens inside a transaction, it is written at the same moment, at that particular moment. So if you try to call a rollback in the transaction, the changes introduced by this bulk operation, and namely insert cache operation, it won't be a rollback. So in some way, it breaks ACID model. But if you don't need to roll back, it works as expected.
Mm-hmm. And that's very good to know. Something we should keep in mind. Now, it's very nice that we can optimize inserts. But if I were to be an application developer doing something with ColumnStore, do you have one general trick that can make my application run faster on ColumnStore? Is there something that's rather easy for me to do, that's not necessarily intuitive first time around, that could make it faster for me for ColumnStore to get me my data faster?
I would even give you two advices. The first advice: don't use star in the projection. So one shouldn't use select star from something, because it takes the whole columns from the columnar table. And usually columnar engines are very good in taking from the disk only the columns that are of the interest in this particular query. So you need to stick with the actual column names in projection, and one should also denormalize his schema, because usually people people stick with the star or snowflake schemas. And this, to some degree, it makes columnar engine slower. But when one decides to denormalize his schema to store all that data in there, it will benefit the query execution timings a lot.
That sounds like a very good idea. I think that on its own is a topic for another talk, which we can probably have at some point.
That is very true. That is very true.
But so the key thing to keep in mind is that I'm not using a row-based storage. I'm using a column-based storage. So don't try to act as if I have all the row data available. As easily.
You have all the raw data available, but you shouldn't ask for everything, because this everything, the whole record, it doesn't belong to one particular block of the data. It belongs to many separate files. So to glue the whole record from these separate files, it takes a lot.
Mm. So if you have multiple files, does that mean that you can do queries in parallel?
Actually, our query execution is parallel naturally, because we are from the MPP lot, massive parallel processing. So we try to execute our queries on the parallel nodes and using many threads as much as possible.
Mm-hmm. Yeah, that's probably one of the reasons why ColumnStore is fast when you need to compute something.
Yes, that is very true. This, and we also leverage a number of benefits that brings columnar files.
Mm-hmm. Okay, and so speaking of files, at the end of your presentation, you mentioned that there is an integration between Power BI and ColumnStore. Now, I know Power BI has lots of integrations with different services and file formats. But it's great that it now supports ColumnStore, or will support ColumnStore. Can you describe more on what that means for the end user, and what did it take on your side to get it to work?
Sure. First, I want to highlight that not only ColumnStore will be a certified direct query source, but MariaDB in general. So one can use even InnoDB tables for querying the data. The direct query mode in Power BI allows Power BI engine to run the queries on the engine side. So it enables Power BI to ask for a query results. And usually these are analytical queries that contains aggregates. So it allows to save network throughput, and it allows to store data on the engine side. So one doesn't need to have an enormous amount of RAM to just crunch the data received from the engine, from the database. So it gives a lot of benefits. One just saves a lot of time that are not wasted on waiting when his data gets from the engine into the Power BI engine, and after that, the Power BI needs to run the analytical part of the query to produce the results. That's the point.
So did I get it right that the processing happens on the ColumnStore side as well, optionally?
I would say it will happen most of the time on a ColumnStore side, and Power BI will receive only a short list of the records that are results of the aggregate queries.
Oh, that's very cool. That will open up lots of possibilities.
That is true. Speaking about effort that we had to put to have this certification, it was it takes us to go through the certification itself, because the Power BI has capabilities to just connect to any SQL speaking engine and run the queries in there. So we just need to produce an API that Power BI understands.
Mm-hmm. Okay, that makes sense. And it's very good that we also got MariaDB as a whole to be supported by ColumnStore. That's very good news.
Yes, that is very true also.
All right, Roman. So these were the questions I had for you. Thank you very much for taking time to answer these. Very good presentation. I thoroughly enjoyed it, and I hope the information here is going to be useful for lots of other people as well.
Thank you, Rick, for calling me here, and have a good day.
Yep. You too. Bye-bye.